Hi friends, this is Anna Dixit working as a teacher for mathematics from 2009. In today's session, we'll see one topic from standard 8, that is rational numbers. Before starting the rational numbers directly, we'll see some real life examples related to this rational numbers. First example we'll see, that is construction of house. For constructing house, we have to draw the map first, and for drawing the map we should know that length and breadth of the our plot, and that are expressed in terms of numbers. We'll see one more example, that is money. For living our life, for getting our daily foodstuff, we require money, and money is always counted in terms of number. We'll see one more example, that is for the measurement of height and weight, numbers are necessary. So can I say numbers plays very important role in our life. So this all is what number system. So in this session we'll see number system and its classification. What are types of numbers? So first type is a natural number. Now if you count anything, you start with what? 1 2 3 4 so on up to infinity. So these are nothing but the natural numbers. So I can define the natural numbers as natural numbers starts from 1 2 3 4 and so on up to infinity. It is denoted by capital letter N. So I can say that N is equal to 1 2 3 4 so on up to infinity. Now the next type of number is a whole number. Now for defining the whole number, I will consider that same set of naturals 1 2 3 4. In this natural numbers set, I will define one more number, that is 0. Then this number set of numbers become whole numbers. So here is the definition for whole number. In a natural number, if we add 0, it becomes whole number. It is denoted by W. So here I can say W is equal to 0 1 2 3 4 so on up to infinity. Now we have seen this natural number 1 2 3 4 so on up to infinity, and in this natural number if we add 0, it becomes whole number. So we'll see some relation between them. For that we'll have some remarks. Now if you observe this natural numbers and whole numbers, you can see that all natural numbers are present in a whole number. So here is my first remark: every natural number is a whole number. For the second remark, if you observe this 0 from whole number, it is included in a W but not included in a N. So I can say that every whole number is not a natural number. Now we'll see third type, that is integers. How I can define the integers? For defining the integers, I will take all the whole numbers first. Whole numbers are what? 0 1 2 3 4 so on up to infinity. Also I have the set of natural number. So take negatives of natural numbers in this set, that -1 -2 -3 -4 so on up to minus infinity. So this is my new set, new collection I can say, and minus infinity, -4 -3 -2 up to 0, then 1 2 3 4 so on up to infinity. So I can define the integers as in a whole numbers. If we add negatives of natural numbers, then it becomes integers. It is denoted by I or Z. Z comes from the German word zahlen, which means to count. So Z is equal to this set, minus infinity, minus 4, minus 3 up to 0, then 1, 2, 3, 4, so on up to infinity. Now again we'll see one remark related to this, that is related to natural whole, relation between the natural whole and integers. Now if you observe this natural numbers and integers, all the natural numbers are included in a integers 1, 2, 3, 4 here, and in a n as well as in a z. So here is my first remark, every natural number is an integer. Now if you observe this w and z, all the elements from the whole number 0, 1, 2, 3, 4 and so on up to infinity, obviously they are included in a z. So here is my second remark, every whole number is an integer. Now we will see the reverse part also. Again observe this natural n and integer z. Negative numbers minus 4, minus 3, minus 2, minus 1 and 0 are not included in a n. So I can say that every integer is not a natural number. Now if you observe this w and z, here again negative numbers are not included in a w. So here is my fourth remark, every integer is not a whole number. Up to this what we have seen, natural number 1, 2, 3, 4 so on up to infinity, whole number 0, 1, 2, 3, 4 so on up to infinity. Then integers are what? All wholes and negatives of natural number. Now we will see the fourth type, that is rational number, which is our main topic. How I can define the rational numbers? See the definition, a number x is called a rational number if it can be written in the form of p upon q, where p and q are integers and q should not be equal to 0. That means q is equal to collection of x such that x is equal to p upon q, where p and q belongs to z. P and q should be integers and q should not be 0. That means denominator should not be 0. What will happen if the denominator is 0? If denominator is 0 of any number, that number is not defined. So q should not be equal to 0. So we will see some relations between the natural, whole, integers and rational. For that अभी हमको मालूम है natural numbers 1, 2, 3, 4. We'll see relation between the naturals and whole, naturals and rational number. Now consider this natural number 2. Can I say 2 is a rational number? रैशनल नंबर किसे कहते हैं? जो p अपॉन q के फॉर्म में है, जहाँ पे न्यूमरेटर है, डिनोमिनेटर है, न्यूमरेटर एंड डिनोमिनेटर्स आर इंटीजर्स. सो यहाँ पे 2 में डिनोमिनेटर इज नॉट प्रेजेंट, एंड जहाँ पे डिनोमिनेटर प्रेजेंट नहीं होता है, कैन आई से 1 इज अ डिनोमिनेटर. सो हियर आई कैन रिप्रेजेंट 2 as a 2 upon 1. So this is of the form p upon q. Now I'll check for second condition, p q belongs to z. Can I say 2 and 1 are integers? Yes, 2 and 1 are integers. And now third condition, denominator should not be 0. Here 1 is the denominator, which is not equal to 0. So here natural 2 is a rational number. I will check for one more number, that consider the 5. 5 can be written as, similarly 5 can be written as 5 upon 1. So I can express every natural number in the form of p upon q, जहाँ पे सभी natural numbers के denominator क्या होंगे, 1. So they are of the form p upon q. Second condition, pq, they all are integers and denominator is 1, so not equal to 0. So can I say my first remark, every natural number is a rational number. Now we'll see second remark. For that we'll see set of whole numbers, w. W is equal to 0, 1, 2, 3, 4. Already we have checked for all natural numbers. So now we'll check for 0. Here consider 0. Can I represent 0 in the form of p upon q? Here 0 can be expressed as 0 upon 1. जहाँ पे denominator नहीं होता है वहाँ पे हम 1 ले सकते हैं. So 0 can be expressed as 0 upon 1. Also 0 can be expressed as 0 upon 5. मीन्स 0 को हम कैसे भी एक्सप्रेस करते हैं, 0 अपॉन एनी नेचुरल नंबर इज ऑलवेज 0. सो हियर इज माय सेकेंड रिमार्क, every whole number, that 0, 1, 2, 3, 4 are what? Whole numbers. So every whole number can be expressed in the form of p upon q. So every whole number is a rational number. Now for the third remark, I will take that z is equal to integers, set of integers, all negatives of natural and all whole numbers. So consider, I will check for all some negative numbers. So consider -3. -3 can be expressed as -3 upon 1. Also -5 can be expressed as -5 upon 1. So all negative numbers here can be expressed as p upon q. Already we have checked for 0, 1, 2, 3, 4, so on up to infinity. So here is my third remark, every integer is a rational number. Now we'll see reverse part of it. For that we'll consider some numbers, 5 upon 3, -2 upon 9, 3 upon 2. Can I say these are rational numbers? Are they in the form of p upon q? Yes, all three numbers are in the form of p upon q. pq belongs to z and q is not equal to 0. So definitely all these three numbers I can say that are a rational number. Now we'll see the given three numbers and set of natural numbers. Observe this. Here all that three numbers are not included in a n. So here is my fourth remark, every rational number is not a natural number. In the similar way you can observe that all that three numbers and whole numbers, again that 5 by 3, -2 by 9, 3 by 2 are not included in the w. So here is my fifth remark, every rational number is not a whole number. Again we'll see last remark, observe this z and given three numbers. Again these natural rational numbers are not included in a z also. So again here is my sixth remark, every rational number is not an integer. Means natural है, natural is a whole, whole is a rational, but converses are not true. So up to this what we have seen, natural numbers 1, 2, 3, 4, so on up to infinity, whole numbers 0, 1, 2, 3, 4, so on up to infinity, integers, negative numbers, positive numbers and 0, that means whole numbers and negatives of natural numbers, they are integers. And we have also seen some relations related to this natural number, whole numbers, integers and rationals. Rationals are what? Number of the form p upon q, where p and q are integers and q not equal to 0. And related to this, some homework I have given. Try to solve this homework. If you have any difficulty related to this video, here at the bottom side I have given my personal number. You can call me on that number for any of your doubt, and please subscribe my channel. Thank you.